Okay, now we are going to begin with the question number 3 of the miscellaneous exercise of chapter number 7. Now in this question we have to integrate this function. Okay. Now this is one of a tricky problem. Okay, and trick is something that if you know that, then you can solve a problem. If you don't know a particular trick, then the problem would not be solved. Okay, so this problem is based on the concept or the trick or the main idea to solve the problem is this, that we place x is equal to a upon t. Okay, on doing this process of substitution, this whole function is going to convert into a very simple function and we would be able to integrate it afterwards. Okay, now in this we place x is equal to a upon t. Then we are going to get dx is equal to minus 1 upon t square. Okay, a was already there, so we can write a upon t square dt. Okay. So instead of dx, we are going to substitute this, and instead of x, we are going to place a upon t. We are going to get this integral as 1 upon a upon t under root of x into a upon t, that is equal to a square upon t minus a square upon t square. Okay, and instead of dx, I am going to place a upon t square. Okay, now we are going to further simplify this. So 1 remains in the numerator. Here I am going to get a upon t as it is. Here I am going to get in the under root t square. Here one thing can be noted is this, that both the terms a square upon t and a square upon t square has a square in the numerator. So we can take this a square common. On taking a square common and outside the root, we can place a. Okay, so I'm going to get this as this a as common. Okay, and the terms which remains will be t minus 1. Okay, and minus a upon t square remains as it is, and dt remains as it is. Okay, the further we can write this as 1 upon a square, because this t is in the denominator and it is 1 upon t in the denominator, so this t is going to come and multiply here. Again we are going to get under root of t minus 1 here. This t square is again in the denominator, which is in the denominator again, so this is going to cancel, so this, and it is inside the root also, so this is also going to become t, which is going to multiply in the numerator, and minus a upon t square dt remains as it is. So this t square cancels out, a and a are going to cancel out, so this power will be removed. Okay, so I'm going to get minus 1 upon a, 1 upon under root of t minus 1 dt. Okay, this can be written as minus 1 upon a integration of t minus 1 to the power of minus 1 by 2 dt. This integration is quite simple and it is very simple to integrate, so this is going to become t minus 1 to the power of minus 1 by 2 plus 1, minus 1 by 2 plus 1, so I am going to write it directly as 1 upon 2. Okay, this minus 1 upon a remains as it is. This 2, again this 2 is in the denominator of the denominator, so it is going to multiply here, and I'm going to get under root of t minus 1 plus c. Okay, because we were integrating in x, so I'm going to get 2 upon a. Now t, we have assumed x is equal to a upon t, so this means that t is equal to a upon x. So this will be equal to under root of a upon x minus 1 plus c. A little bit of simplification is left. This is going to become 2 upon a under root of a minus x upon x plus c. So this is our required answer.